So let's pick a friend. Oh, I already got one. Wait, no. That was last hour. That's right. I do know student number 20 went last hour. Nice. Oh, you were tardy today. Good. I'm glad you get to go first. This is nice. Okay, look at your sheets. We're done with like at least what I put on that. Look, you have your little quarter sheet. Hold that up. Okay. Go to this side with the sum. What's the sum formula for is it cosine cosine then sine sine, or is it cosine sine cosine sine? Which one is it? So it's cosine of x, right? And then what is it, plus or minus? Minus sine sine. So what we're doing is just making a connection through the sum formula that we could derive a new double angle formula. Okay, so let me reiterate my thoughts here. We're done our quiz Thursday, except for knowing tangent, sine over cosine. Those basic identities. We're done with an identity quiz. Now it's just all using. So you will have that sheet in front of you, just like we did on the second part of our quiz Thursday before spring break. So this isn't really needed. It's just a neat little, how could we get this from another formula? Now here it is. Now, why? Not that you care, but you do kind of have to care. Why does cosine of 2a or double angle have three different things? It's simple. Everybody, no, Kathleen, what's sine squared plus cosine squared equal to? Do you remember that from before break? What's sine squared plus cosine squared? I'm trying to get the microphone. It's a number. What number? Do you remember? 1. Are you saying it or no? Oh, I can't hear you. You're in speech, remember? Project that voice. Okay, speech club. So if I put 1, okay, so sine squared plus cosine squared equals 1. Subtract sine squared. Cosine squared is 1 minus sine squared. Can you hold that thought, right? And if I put 1 minus sine squared minus another sine squared, then that turns into 1 minus 2 sine squared. You don't have to know this, but I kind of want you to know why there's three different forms of this formula. It's because of a Pythagorean identity substitution. Sine squared is 1 minus cosine squared. When you distribute that minus sign, then the cosine squared becomes positive, and now you have 2 cosine squareds, minus 1. But what you do need to know is you have 3 options. Sometimes you want to choose one of the particular 3, depending on what kind of question you have. And I might at the end of this video open up the homework block and give you some hints on some stuff, and it really pertains to that. All right, and then here's the other 2. Don't have to have them memorized, you just have to use them. All right, and then we made a choice last section to not have questions like this. Last section, we had questions where you had to do the cosine of 105. By the way, what's 105? What plus what? Don't just say 100 plus 5. I want 2 angles that when added together, well, those 2 angles are special. So let's actually pick on someone else. 2. Nice, Jennifer. I hope I remember all your names. Is that right? All right. What's 105? What plus what? That ends up being one of our special angles that we had from chapters 2, 3, and 4. Actually 2 and 3, not really 4. 4 was the graphing. And then what we would do is then we'd use the cosine formula and use the 45 and 60 in these positions and go from there. That was our last test. So that was the only kind of questions. We didn't have any questions like this. But I'm going to reverse it. We're going to do questions like this in this chapter, and you don't know what I mean. This is what I mean. This has nothing to do with 30s, 60s, and 45s. This is just they give you a general piece of information about theta. Sorry, I didn't mean to do that. About theta, and then they want you to find sine, cosine, and tangent of 2 theta. And all you got to do is use the rule from your sheet, the identity. So here's what you got to do on this. And then who do I have here? Jennifer. What letter then for theta does 3 represent? So cosine of theta is 3 over 5. What letter does 3 have to be then? It's a chapter 2 question. So it's either X, Y, or R. I'll just do that. X. And then what's 5 then? Do you know what 4 has to be then? It's one of the special Pythagorean triples. You don't know the Pythagorean triples? Okay, so then this is what we have to do. Oh, before I continue, this is a triangle where theta is positive in for cosine, but negative for sine. Notice these both say theta for the argument for the angle measure. So where is cosine positive, but at the same time sine negative? What quadrant is that? Then I'll move on and then we'll finish this with somebody else that the calculator chooses. 4 is correct. And now we'll move on to student number 11. Where the heck are we on that? 8, 9, 10, 11? Is that Matt? Are you 11? 4, 8, 9, 10, 11. Yep. We were talking about you last hour. Santino. All right. Okay. Whew. Okay, so we're in quadrant 4. And she already told you that this is 3 and this is 5, x and r. She didn't tell me what y is. Do you know what it is now? It's 4. But you're a liar because it's actually what? What kind of 4? Negative 4. I'm sorry for calling you a liar. All right, so you got to read the information. All right, and then how does this help me? First of all, we got to know that this is theta. That's theta. That's theta's triangle because they gave me theta information over here. We're going to use this theta information to find 2 theta information. Matt, look at your sheet. What does it say that you don't have to have memorized what sine of 2 theta equals in terms of theta? Or just tell me what sine of 2 theta equals. So don't tell me the A's. Fumble. So what's sine of 2 theta? Read off the sheet. The sheet that has sine of 2a. You got to be able to make that. There we go. Look at all the friends helping. This is nice. Isn't this fun? This is great. It equals 2 sine a cosine. There's no A's. So 2 sine what? Okay, there you go. And then now look at what we can do. We can go ahead and evaluate because, well, first of all, what's cosine of theta? You can't miss that. It was 3 over what? 5. Oh, guess what's coming? Starts with an F. Which makes students say an F word. No, I'm just kidding. That's terrible. Fractions. Yes, let's just leave it at that. Wait for the other one. What's sine of theta? Sine of theta is negative 4. And then notice how this is not like the questions we had in the past where you're not dealing with 30s, 45s, and 60s. This is just a different way of working with these other forms. We could have done questions like this in section 5.4. We decided not to. Yeah, and I'll just leave it at that. Okay, so here we go, Matt. What's the final answer? Oh, this multiplying fractions. This didn't go well. It was a really good student last hour, and it was just like deer in headlights. Oh, my gosh. I was just off a spring break there. Don't faint, Matt. Ashka just stole all the oxygen from the middle of the room with that big yawn. Is it negative 2 over 5? Oh, you're killing me, Small. So what do I got to do on the top? I got to multiply across. So what's 2 times negative 4? What's negative 8 times 3? Negative 24 over, and then multiply all the bottoms. 25. There you go. So that's how we multiply fractions. This should be in a no calculator scenario. You dang seniors in your fractions. You multiply the numerators. You multiply the denominators. All right. And then, all right, cosine of 2 theta. Nice. Mitchell, is that your name? All right. It's been a long break. Cosine, let me put this way over here. Because in the last hour I ran out of room. Let me just go all the way across here. Now, you make a choice. Look at your sheet. What do you think you'd want to use? There's really no wrong answer here, but I think some are a little bit easier than others. I think that one might be easier. I don't know. Last hour we did 2 cosine squared theta minus 1. We had to multiply 2 a fraction and then subtract 1, and it seemed to be maybe a little tedious fractional wise. Okay, so what's cosine of theta again? So this is how you have to write it. It's 3 over 5 squared. That's what cosine squared of theta means. And then what sine of theta again? Okay, so I have a question. Should I Should I cancel these negatives? Yes or no, Mitchell? Should these cancel right there now that I made that substitution there? Absolutely not. That's PEMDAS violation. You have to do exponents first, then subtract. I should have this showing that when I walk to the screen. A little out of practice with this, when I move to the screen there. But anyway, so no, you don't. So what's 4/5 squared? I think I'm going to run out of, yeah, and then what's 3/5 squared? Sorry, I messed myself up. So it's 9 over 25 minus 16 over 25. This ended up being a little bit easier than last hour. Last hour we had to do some common denominators with the 1. What's the final answer? -7 over 25. Now, I am going to do the hardest of these 3, but you actually could probably answer this question now. Somebody last hour, Santino, actually came up with this answer. What is the tan of 2 theta? Let's see if anyone can make a guess here. I'm going to circle these last 2 answers, though. There's the cosine of 2 theta. There's the sine of 2 theta. So what should the tangent of 2 theta end up equaling? Understanding that 2 theta is the same angle measure, whatever it may be. Santino was able to get this answer last hour without doing the formula. We're going to still do the formula because you got to know the math involved with fractions. Nobody? Oh, so close, and you made a mistake on one simple thing. Positive. See, what letter does this represent for 2 theta, everybody? Not theta, 2 theta. So whatever theta is, we have to double it. That's where 2 theta lands. This letter is what? Y. This is what? R for 2 theta, whatever that angle measure is. What letter is this? X over R. So what's tangent? Y over X. So it should end up being 24 over 7 when we do this. But we're going to do it because this is the math that gets a little bit complicated. Who's 17? Nice, Ivo. What's tan 2 theta? What does it say on your sheet? I'll be right back. Do you have a sheet? Okay. Do you need one?
Yeah, please.
Were you absent? You get this one.
You literally ripped out through what?
You should fold it. It's easier.
Yellow extra. Yeah. Oh yeah! All right. So what do you get? Tan 2 theta is equal to? Yep, 2 tan theta, and then what? So I think it's 1 minus tan squared theta, right? Okay, now this is where you get confused on it. Now we got to go to theta. Theta is this triangle where I know the 3 sides. So what's tan of theta, which we're going to put in this in 2 different positions. Here's theta. Here's theta's triangle. This is the reference angle if you want to go back to math 2 and just do SOHCAHTOA, TOA, TOA, TOA. So what's tangent? Or circumference or ticks. So it would be what number over what number? -4 over 3. Now we're going to type that in 2 spots. Type 1 minus. What's tan squared of theta? It's tan of theta. And then it's squared. So imagine that, and again, you probably, not many people would be able to figure out the 24 over 7 thing. You wouldn't think that in this question. It wouldn't be in your mindset. So this is a harder mathematical structure. Again, because we have fractions. I really should do one more of these. I think I might make up one. Just because I want to deal with when we have multiple radicals. Okay, so first of all, Iva, what's 2 times -4/3? That just happened last hour. That's not squared, right? So it's just 2 times. And by the way, it's 2 over 1. You did another mistake. -8 over 3. All right. So you squared for some reason. Negative 8 over 3. And then this is 1 minus. Okay, I'll give you that 6. Oh, I forgot to ask you. Am I supposed to cancel those negatives? I hope you were listening to the last one. Heck no. Heck no. By the way, on the bottom, this is 9/9. So to save yourself a step, that's what you would do. So what's the bottom become? What's 9/9 minus 16/9? What kind of 7? 9 minus 16. I have $9. I owe my friends $16. I pay them 9, and I'm still 7 in the hole. Okay, and then how do you divide a fraction? It's multiplied by its Ivo? Nope. Reciprocal. Okay, now what's a negative times a negative, Ivo? This is why I get angry about students saying this is tough. This is grade school right now. This is Lexi Samuelus. All right, mathematics right here. Then who else cancels? Who else cancels? Who else cross reduces? Who cross reduces? Who can I reduce across? Cross cancel. Not cross multiply, cross cancel. Who goes into who? What number goes into what number evenly? Does 7 go into 8 evenly?
No.
Does 3 go into 9 evenly?
Yeah.
How many times?
Thrice.
Thrice. Isn't this fun? Hey, I have a question. What's 3 times 8? And then what's over 7? That's not even a question. 24 over 7. This is what we said in the first place. Isn't that right, Alexis? Long time ago, right? So at least we proved that could. Hey, let's see if you can be like Santino. Theta is in quadrant 4. These are just fun little questions to ask. Where does 2 theta land? Knowing sine of 2 theta is negative 24/25. Cosine of 2 theta is negative 7/25. And then tangent of 2 theta is positive 24/7. Anyone? What quadrant would that be? Not 2. 3. Right? So 2 theta would have to be in quadrant 3 because, well, look at it. That's the y value. That's negative. That's the x value. That's negative. How you get a negative x and a negative y is quadrant 3. So making these connections, understanding what is 2 theta compared to theta, it's double this angle. So it could land in probably quadrant 2 or 3. I'd have to think about that. What's 540? I think it would have to land in quadrant 3. No, it could end up in quadrant 4. What's 2 times 360? Nobody cares anymore, but what's 2 times 360? So double a quadrant 4 angle measure, you might be in 3 or 4, right? So that's what's going on here, but whatever. I should do one more. I'm just going to make up one, and I don't care. I do like this one. Let's say we have this, and let's do tangent. Sine of theta equals, let's say negative, I like it, negative 3/7. Let's just say theta in, it would have to be 3 or 4, by the way. I'll pick 3. Find tan of 2 theta. We'll find the hard one. Okay, so we'll find the tough one here. Well, the first thing you need is for tan 2 theta, that rule is tan 2 theta is 2 tan theta. Just look at your sheet. You don't have to have this memorized. I'll actually leave you alone on this. Maybe I won't. Maybe we'll bully you in answering questions here. So that's the formula. So I need theta information. So I need to draw this triangle. You don't really have to draw it, but triangle. So we can equate this to a quadrant. What? A chapter. Actually, chapter 1. We did a question like this in chapter 1. Okay, so there's my triangle, right? Opposite and hypotenuse, correct? So how do I find this? I got to use the what? Starts with a P. Pythagorean Theorem. Who did I just, Ivo. Oh yeah, we tortured Ivo. 19, nice, Matt. So the Pythagorean Theorem, we got to find x. And by the way, it's going to be a negative. X squared plus negative 3 squared equals 7 squared. What's 7 squared, Matt, just for fun? What's 3 squared? What's 49 minus 9? You should be able to get here as a senior with the Pythagorean Theorem. And then square root of 40. Oh, no. This is why I'm glad I did this. What's 40? What times what? 10 times 4 is correct. What's the square root of 4? 2. So this is 2 root 10. Oh, we're wrong. It's negative. We got to remember that this is here. Okay, so this is why I'm doing this one. This is going to happen to you in your homework. All right, I really got to check that homework. Hopefully it's not I'm thinking about what the questions might be in there. Okay, so what's the tangent of theta? What goes in here? This is going to be worse than I thought, but we'll get over it. What's the tangent of theta then? This is theta. This is theta's triangle. So it's negative 3 over negative 2 root 10. Sorry, fourth hour, we didn't do one like this. And then 1 minus the same thing. I'm not going to ask you again. And actually, we're going to leave this. Because then what we have to do is square it. Why did I make it positive? Because negative over negative. So I got that figured out here. Okay, now we're in a little bit of trouble. I will tell you this for the test Thursday. I did say that. You at least got half credit so far. At least if I can see you get X and I can see you plug it into the correct formula, that's 2 out of 4. At least we got that going. If I see at least something moving on after here that has some math to it, I'll give you another point and give you 3 out of 4. Because here's what's got to happen first. These 2's cancel. You got to know how to cross cancel to make your life easier. And then what I end up having here in the top is 3 over root 10. All right, and I could attack this a couple different ways. I'm going to hold off. I want to get the bottom taken care of. All right. In the bottom, actually, the squaring helps. I'll move on. We should know how to do this. 15. Who's 15? That feels like this row here. 11, 12, 13, 14. 15. Nice. All right, so here we go. What's 3 squared? It's simple. What's 3 squared? 9. What's 2 squared? It's simple. What's root 10 squared? What's 4 times 10? 40. So guess what I want to make 1? I want to make 1 40 out of 40. And now I have a common denominator. This is how you go about like simplifying this. You make it easy on yourself by doing little parts here and there. So one more time. 3 squared is 9. This is a product squared. Square each part of the product. 2 squared is 4. Root 10 squared is 10. 4 times 10 is 40. That's how I got 40 so quick. We should be able to do that as seniors. What's 40 minus 9? Okay, so now this is what I want to do. Now we're going to become seniors and deal with this quick. The numerator becomes 31 over 40. This is 40 over 31. Right? I did the flip. Correct? Okay, now I've avoided something. I guess I should have done this a long time ago. What do I have to do about that root 10, everybody? Starts with an R. No canceling. R-A. R-A-T. Rationalize. What do I multiply top and bottom by? Root 10. Because I got to kind of do this now because I heard someone say cancel. No, I can't cancel the root 10 with a 40 out. But now that I've rationalized this, what I have up on the top is, and I'm writing this kind of weird, I'm writing this like this on purpose so that I can really see these cancel. 31 times 10, and now I can cancel this to be just a 4 there. All right. And then what I end up with is 12. What a monster. Root 10 over 31. Ouch. All right. So, yeah, 2 more points. If I see something about an attempt to do a little bit in the denominator, get another couple things correct, but miss the final answer, you get 3 out of 4. There really isn't any excuse not doing the first part, and then substituting there. So that would probably be like the hardest on the test, unless you don't like identities, which that's what this is. Okay, so let's remember how to verify an identity and look at how many steps we have. All right, this is going to be not too bad here, but let's get a person. 19 again. Nice, Matt. Hey, man, I think I've said quite a few times, good FOILers are what? That was a hint. Which side am I going to work with, the left or the right? What can I do with the left side? Just give you a hint. Factor. This is a difference of two perfect squares. How does that factor? This is step one. Tell me what you'd write then. Factoring this is a difference of two squares. The ability to see trig as variables. And that's why we should be able to factor pretty quick here. And then what else? Remember, for x squared minus y squared, how does that factor, by the way? Because that's what you're missing. You're missing the two factors. You only gave me one answer. I think what you do is what a lot of people do. They just square root, and then they just write that. So what's x squared minus y squared? What is that? What times what equals x squared? Xn? And then what times what equals negative y? It's that simple. Minus y, and then what's the other one got to be? Remember that? That's the format for difference of two squares. That's what you were missing with the trig. So you said, what did you say first? Cosine squared minus sine squared, right? Yeah. Times. Oh, you said minus twice. It was opposite, right? Yeah. All right, so it's opposite. So you did say minus first, I thought, unless I'm wrong. But it's cosine squared minus sine squared times cosine squared plus sine squared. Again, good FOILers. Say it, everybody. Good factors. This times this is the cosine to the fourth. This times this is the negative sine to the fourth, theta. What happens to the middle term? I'm tired of teaching factoring and foiling. The middle term completely cancels because they are opposites of each other. So that's what good FOILers, good factors means. Oh, shoot. Let me go back. Good. Okay. All right. Now, let's get to somebody else. Even though you just saw the answer, if you just saw it. 13. Who's lucky number 13? Now, I feel like is that one of these two? Hope you're having fun in Florida. Kids these days, school's optional, apparently. Hey, Kathleen, loud and proud. I can't believe this. I'm going to ask you the exact same question. What's sine squared plus cosine squared? This is so funny. The calculator picked you again. 1. And then look at your sheets. What is cosine squared minus sine squared equal to? What is that equal to? Look at your identity sheets. Look at the right side as well of this identity because it really steers you in the direction. What does this equal? Look at your sheet. Look at the right side. Look at your formula sheet. What does the blue equal? Cosine. Look at the right side. 2 theta. And then I really don't know if you have to write the next step because 1 times anything is the thing. Put yourself away already? I hope you get picked. Dang it. Ooh, she gave me a dirty look. All right. Okay. All right, we're not doing this. Oh, yes, we are. Okay, now actually, this is just like 1 through 6 in your homework. I pull it from a different section. Hey, look at your sheet. What does that look like? Thanks. Well, your voice has changed. Tan 2 who then? Tan 2 who? Tan 2, what's theta? Huh? What's 2 times 15? What's the tan of 30? Let's sit here and see if you got this memorized from chapter 1, 2, 3. Remember this? Then real quick, what's the side opposite to 30? Oh, I hope you know this one. What's the side opposite to 60? I think I heard you. What's the side opposite to 90? Blah. Now, TOA. So at least, if you can't have these memorized, you've got to at least extract the answers instantaneously from that thing. TOA, which is 1 over root 3 rationalizing ends up being root 3. There we go again. Even the students from the back in the day, I threw one in a coordinate plane. You almost don't need that anymore. You just need the SOHCAHTOA and then what quadrant I'm in. Kind of thing. So that's what this is, kind of using the formula in reverse with some angle measures. 12? I feel like that's one of these people. All right, 13, 14. Oh, yes, good. You put your sheet away. Which one's this? What does that represent? Oh, did you take it back out? Good. That's a cosine, huh? To who? Cosine to who? Sound like Horton Hersey. Here's a who. I can't even say it. Huh? So what's 2 times 22 and a half? No, what's half of 2? So what's 44 plus 1? Ooh, I got a text. I'm not going to check because phones are illegal. Did you hear that? You're jealous of that Yoda laugh? What's cosine of 45? This is fun. I watched The Office all day. Well, quite a bit Sunday. Then I watched some movies. Obscure 1974 movie. I wouldn't recommend it. Did you say George Patton?
Oh, did you watch that?
Oh, yes. I thought you said Patton. Like, it is from the 70s. Were we? Huh? Okay, so 45, 45, 90. It's the 1, 1. Oh, for the love of dog, this computer. 1, 1, root 2. That's what the 45, 45, 90 sides are. Cosine of 45 is, so what does that become? The root 2 over 2. So we should have that one memorized. I'm going to get on you on that one. All right, so it is mirroring this one, so that's why it's 2 times that, this is everything that I verbalized. I didn't want to give away. Oh, and then, yeah, this is what I did draw the triangle real quick for my students even in the past. That's your fallback. I'll tell you right now, if you went into tutoring and like you had Wilson, for instance, she used to have this as juniors to seniors. She would yell at you if you have to keep drawing this. But you better do something because we shouldn't be missing those questions from chapter 2, and 3. This one's kind of stupid. I'm still going to do it. There's going to be nothing like this on the test, but I just got to ask you 16. Nice, Sam. All right. Wait a minute. You have a key? Is it what? Oh, that's KU. I thought maybe we were in a Kansas jersey. That's right. Anyone rooting for Kansas tonight? That's good. It's just shake no over there. Wife's family's from Kansas, and my 2 girls wore Kansas sweatshirts today. Nobody cares, Mr. S. Okay, so let's factor out a half. If I factor out a half, what does this 1 become? So if I factor out a half, what does this 1 become? Say that. Itch my nose. 2! And then when I factor out a half, what does this become? When I factor out a half, what does that become? 1. And then what does this emulate? Which formula is this? Which formula is that on your sheet? It's just my friends, they're just he's trying to get one friend that he just spends all my money. He really does. I'm broke because of this guy. Vacations. Let's go to the Sox game this week, next week, the following week. Sorry, what's up? Cosine 2. So cosine 2 who? What's 2 times pi over 8?
Pi over 16.
Seniors. 2 pi over 8. The 2 and the 8 cancel. What does that become? Pi over 2 goes in 8. How many times? 4. And then that pi over 16 would like blow your mind because of what? But pi over 4, what is that? What's pi over 4? What kind of angle measure is it?
45.
You better get this right because it just happened. What's the cosine of 45? Almost still on the.
Root 2 over 2.
And then what's half of that? Okay, so that's what ends up happening with this. Half of that is root 2 over 4. So that's kind of a stupid one with that fraction out at the end. All right, I'm going to torch you for one more. Isn't this great right at the end of a break? Nice! Nate looks so happy. We ain't doing that one. we are doing this one. No, I'm going to help you, and you would get a clue on this. Flip your sheet. You don't even have a sheet. No, Nate. Okay. Were you absent for that? Or you just lose yours?
I just lost it.
No. Okay. So I would give you a hint. Actually, I remember this being a test question, or at least one like this. And the hint that I gave for my class is, you actually might argue with me here. You can work with the right side. That is more complicated, but I'm going to force you to work with the left side. So I'll give you step one. Step one is, let's do what we did at the beginning, proving these double angle formulas by using a sum formula. Okay, now you did have a quiz on this where you did have to know the sum formula. What was sine sum formula? Was it cosine cosine, then sine sine? Or was it sine cosine?
Sine cosine.
So our first step is sine of the first angle, cosine of the second. And then what do you know about the signs? Is it plus or minus? Is it signs the same or not?
Stay the same.
Signs are the same. And then what's the next step? So it's sine cosine plus
Cosine sine.
cosine sine. This may confuse you. Cosine of the first. I never did that. What I would do, I'm going to write this way, but if you followed the formula perfectly, then it's cosine of the first, sine of the second. Now this is what I want you. This is not part of the idea, but I just want this off to the side. Hey, Nate, are these like terms, yes or no? QR plus RQ.
Yeah.
Yes. So I really should have the ability to write RQ as QR. And then what's QR plus QR become? Just answer that question. Don't listen to that person.
2QR.
2 QRs, not QR squared. That's how you add like terms even when there's multiple variables. So what I'm getting at is that emulates this. So what does this become? This plus that is how many of those? 2 of them. All right, now we're getting somewhere because I have 2 of these, sine 2x cosine 2. And this is kind of a tough thing to see for students. So I won't be mean on that. You know, oh, you seniors and fractions. I'm going to be mean about that. I'm going to continue to be mean about that. But this one, it's hard to see variables in trig, or trig has variables and has like terms, and this is what happens to all the arguments, like all the parts. That's why I threw simple algebra off to the side to compare to complicated algebra. And then you notice we're almost there. We're almost there. I hate this computer. I really do. Hit it like that. You got it? Did you get it? Did you get it? Good. Thanks, computer. All right. Thank you. Sorry. Throwing a little fit after break. I see the computer is as jerky as ever. And then also I notice a bunch of products, right? So I no longer have a sum. I don't have a sum. I have a bunch of products, and I have one of the parts correct. Now notice that these are x's and x's and not 2 x's. So I'm going to change this. And then who am I going to pick on? Who's the last person that thought they got away with? Nice! Your little friend up here didn't get to go. All right. What's sine 2x? What's sine 2x? Yep, you should be looking at that sheet because you do not have to have this memorized. But there's no thetas. There's what's here? No, what variable? Whoops, that's not a 0. I don't know what. My mind's going crazy there. Not theta, but what letter? That's all I was asking. Oh, and then look at that. 2 sine x cosine x. What's 2 times 2? Fumble. And then this does match the other side. Sorry, I'm going a little too far there. Then this one's in the way. So step 5. Sorry. 4 sine x cosine x. And then I know this is kind of silly stuff, and but identities do have a purpose, like in engineering and all that other stuff, and to be able to work with them. And this is just a general idea of kind of stuff there. Matching an identity, for sure, we match both sides. Okay, done. I looked at the assignment. I said I was going to maybe do that now. What time do we have here? Is that bell ring at 55? It'd help if you'd listen. I'm going to try to help you on some of these just to show you what the assignment looks like. I do like it, but I there's a couple I want to maybe steer you a little bit more. Trig book, PDF, good. Chapter 5, good. This is 5.5. I like this. I think the book I have online, you have to scroll a lot of pages. Sometimes this gets locked up. Okay. You looking at your phone? Oh, okay. Oh, you all right? Jeez, another look of death. All right. Okay. So I'm trying to zoom in here. These should be fine. Actually, didn't I just do number 2? This is number 2 in the notes. I think it is, right? I have no idea what this computer is doing right now. Okay. All right. So, and I think we should be fine here. Good. They're only asking to do a couple things. This is good. This is a good little section here. Oh, this is perfect. We did ones just like this. But it's this one. I had 37. Hey, by the way, good foilers, anyone? Look at that. If you don't foil that, you make me mad. Arr! Okay, and then what did I say next? Number, I think it's 44 and 45. 44. First of all, who's more complicated, left or right? Notice on the right side, there's no fraction anymore, but I know what cotangent is. It's cosine over sine, so that's what I want to have happen on the left. So I want to get rid of this 1. We have 3 choices for cosine 2x. Which one should I use? The one that has, look at your sheets, the one that has what may be in it? So that the numerator simplifies pretty fast. A negative 1. The one that has a negative 1 in it. Because what's negative 1 plus 1? 0. And then you start getting stuff happening. You have only one choice for sine 2x. And then that one's actually really easy if you choose the right thing. If you make cosine 2 theta cosine squared minus sine squared, you're not doing what an identity is, trying to simplify to make it match the right side. You have 3 choices. Choose the smart one. And I am going to use the word smart because we got to look at that and use that appropriately. Then when we look at this, I think, seeing that I have a subtraction here, I know one of these has a subtraction in it with 2 different trig functions. So I think I know what I would choose for that cosine 2 theta to try to match the right side. Anyone see what I'm talking about there? Yes, no? Maybe, maybe not, but yeah, I think that's what's going to happen. So I want to choose a different one for this one because I'm trying to match the right side. So this one's a little bit more challenging, but I would hope half of you or more would actually get that one right. And maybe I'll show you that one tomorrow. Okay, anyway.